Let's solve the maximum sum of a subarray of size k algorithm. Here is the array. The values are the numbers in green, and the smaller numbers above are the index positions. Notice our first index position is 0, and our last index position is 8, which means our array length is 9. In this example, k is equal to 4, so our subarray size will be 4. Now let's visualize an intuitive approach to solving this. The first set of 4 contiguous numbers is our first subarray. So we just take the 4 numbers, add them up. The sum of the first subarray is 17. Then we take the next subarray of size 4, calculate that sum. The sum of this subarray is 39. And we do that for each set of 4 numbers until we've reached the end of the array. Now that we've reached the end, we've calculated multiple sums derived from all subarrays of size k. We can see these here in blue. All right, now that we know what we're doing, let's go back and look at our problem statement. Given an array of integers and a number k, find the maximum sum of a subarray of size k. We want to return the maximum sum. Here are the sums. What is the maximum of these sums? 39. We want to return 39. Now, how do we do this with code? I'm going to code this up in JavaScript and Python. We'll do a side-by-side comparison with JavaScript on the left and Python on the right. I'm going to start with an outer loop that stops at the array length minus k. The array length is 9, k is 4, 9 minus 4 is 5. So we'll stop at index 5. Now we're going to stop here because if we go past the array length minus k, there are no longer enough items to contain a subarray of size 4. So we have to stop here to have a subarray of size 4. The outer loop is important. I want to take a detailed look at this. In JavaScript, here's how we set the starting position. We want to set the starting position at index 0. This is our loop run condition. This loop is going to run as long as I is less than or equal to the array length minus k, which is 5. So once we get to 5, we stop. And this is our increment setting. In Python, I'm not including the start condition and increment setting because the default start and increment values in the range function will work for this problem. I only need to set the condition for the loop stopping point. Now, so here you see I have the length of the array minus k, but in Python I'm going to add a +1 because the stopping point here is going to be exclusive. So if I don't add the +1, the length of the array minus k is 5, but the stopping point is exclusive. I need to add 1 to include the 5. Now I'm going to add an inner loop that sums the remaining values in the subarray. The inner loop starts at I plus 1. So the outer loop starts at I, the inner loop starts at I plus 1, and runs as long as the index is less than I plus k. I is 0, k is 4. So we're going to run as long as we're less than 4, which gives us these first 4 numbers. If that sounds confusing, let's take a look at a visualization of what's occurring here with the outer and inner loop. But this is our mechanism for generating our subarrays. The first item in the subarray is generated from the outer loop, and the remaining 3 items are generated from the inner loop. The inner loop runs as long as this position is less than I plus k, which is 4. So we stop at index 3 for the first pass. And we simply go up 1 and continue until we reach the end of the array. So we have the mechanism for generating the subarrays. Now we need to calculate these sums for each subarray. I'll create a variable called sum and give it the value of I. So if you look at the bottom here, I'm keeping track of our sums. So I is equal to position 0, which is a value of 1. So right now our sum is 1. Then we go into our inner loop, and now we simply add the sum variable in our inner loop so that we add the remaining 3 numbers that our inner loop generates. So in I plus 1, that is 4, so now our sum is 5 because 1 plus 4 is 5. Then we move on to the next, which is 2. 5 plus 2 is 7, and then we reach 10. 10 plus 7 is 17. And now we stop because we can only run until j is less than I plus k. In this case, I plus k is 4. So now I have my subarray sums. Now I need to know the maximum of these sums. Now I need to return 39. So I'll add a variable for max sum and set the value to 0. Within the scope of the outer loop, I'll use a max function to compare the max sum versus the running sum. If the running sum is greater than the max sum, we'll replace the max sum with the running sum. So this first pass, our sum is 17. 17 is our running sum, which is greater than the current max sum, which is 0. So now 17 becomes the max sum. Then in our second subarray, our running sum is 39, which is greater than the max sum of 17, so 39 becomes the max sum. And our third pass, 38, is not greater than 39, so our max sum does not change. Our max sum is still 39. And as you can see, for the remaining subarrays, we never replace our max sum because our running sums after the second pass are always less than the sum of the second pass. Now, there is a problem with this approach. Here's the first subarray, and you see addition operations are performed for 1 plus 4 plus 2 plus 10. Notice when we get to the second subarray, we're repeating addition operations. We've already performed addition on 4 plus 2 plus 10 in the first subarray, and we're doing it again in the second subarray, and in the third, and the fourth, and all the remaining subarrays we're duplicating addition operations. By the time we've reached the end of this array, most of the operations have been repeated 2 to 3 times. For a small array of this size in this example, this really isn't a problem, but with a larger array of tens, hundreds of thousands of values, performance issues can occur and your application just may crash altogether. So we don't want to do it this way. Here's how we do want to handle this. We are going to go ahead and calculate the sum of the first set. So we are going to go 1 plus 4 plus 10. That's fine. We are going to add these up, but we're not going to add the remaining subarrays in the same manner. For the remaining subarrays, we're just going to modify the sum by adding the next incoming number into the subarray and subtracting the number that falls out of the subarray. So here's our first sum. We add these, this is our first subarray. So we add these up, we get 17. Now we move on to our second subarray. We're not adding all of these numbers up. We're simply dropping the number that falls out of range and adding the number that comes into range. So the number that falls out of range is I minus k, because right now I is 4. 4 minus k, which is 4, is 0. 0 is out of range, so we drop the 1 and we add the 23. And we continue the process. In our next subarray, I is 5, k is 4, so 5 minus 4 is 1. 1 is out of range, so we drop the 4 and we add the 3. And we continue until we've reached the end of the array. Now let's compare the changes that we need to make to the first loop. Here's how we're going to construct our first loop in JavaScript. The difference is we're only going to go through the first 4 items. We're not going to go through the full length of the array minus k. We're only going to the first 4 items, and then we'll exit the loop. And here's how we would do that in Python. And again, I don't need to say less than because the length of k is the last item is exclusive. So this is all we need to do in Python. So we'll initialize a total variable, set that to 0, and this is how I'm going to add up the values in the first four numbers in the array. Now again, we're not going to add the remaining subarrays that way. We're going to take our running total, assign that to a variable called current total, and then we're going to take a second loop. Now notice this loop is no longer, we're not doing an inner loop. This loop exists outside of the first loop. If this were an inner loop, as we were doing in our first method, that would create a quadratic time complexity and would result in the duplication of operations, which is what we want to avoid. So if we run two independent loops, this will keep our time complexity to a linear time complexity, which is an improvement from what we were doing previously. So in our second loop, we're simply we're saying I is equal to k. So by this point, I is 4. So now our second loop is starting here. Our first loop went through these first 4 numbers. Our second loop starts here. And I need to take my current total, which is 17. I need to add I, which is 23, and I need to subtract I minus k, which is 1. And that is how we avoid duplication of addition operations. And then, of course, we need to return the maximum of these sums. So we add a variable called maxSum. We'll assign the current total to that maxSum because at this point when we're assigning this, we only have one total, which is our first pass, which is 17. And then on our second pass, we're saying 39 is greater than 17. So this is where we get 39. And then in the subsequent passes, the current total is never greater than 39, so that's never replaced. Now let's go ahead and take a look at this. Let's go ahead and run this code and just make sure that it works. So here's the code that I have in JavaScript. And let's run this and just make sure that it returns the correct result. And our JavaScript did return 39. Let's take a look at Python. So here is the code in Python. And our Python code is also returning 39. So that's how I would approach this algorithm. You may have a better way of doing this. If you found a better way of doing this, let me know in the comments.